In this video, we are going to be taking a look at the different levels of measurement. So we have four main levels of measurement. The first one is the nominal level of measurement. Just as the name says, it's nominal. It goes, if you think in French, le nom, it's just the name. So you are dealing with qualitative data. It's only qualitative data. There's no quantitative data under the nominal level of measurement. So we are looking at names, we are looking at labels, we are looking at qualities, for example, beautiful, handsome. Labels, you are looking at the labels on something, maybe the brand. You are looking at the names of people, Peter, Paul, John, Doe, and so on. There's no mathematical computations that can be made. You cannot say Montreal multiplied by Quebec City minus Trois-Rivières. That will make no sense. The next level is the ordinal level of measurement. Now, when you think of ordinal, think of the ability to order something. You can order things, you can rank it. That's the ordinal level of measurement. It can be qualitative and it can be quantitative. So you can use both qualitative and quantitative data set. Why can you use qualitative? For example, if you think of gold, silver, bronze at the Olympic Games, you can rank it. If you think of first, second, third, you can rank those things. And if those things, so that's why you are able to rank qualitative data here. So that's the ordinal level. So data can be arranged in order or ranked. Differences between data entries is not meaningful. You cannot say first minus second or gold minus silver. That will make no sense. You can just rank things here. Now, when you move on to let's take this few examples. So it says two data sets are shown. Which data set consists of the data at the nominal level? So you are talking of just names and you cannot rank things. And which data set consists of a data at the ordinal level? So if you take a look at it, it's saying the top 5 TV programs, and it has given you the top 5. So already you can see that you have ranked things, first, second, third, fourth, fifth. However, here there is no ranking. You just have the names of the networks. So of course, you are dealing with the nominal, and where you can rank, you are dealing with the ordinal level of measurement because you can rank there. Let's take a look at the next level of measurement. You have the interval level of measurement. Now here you are dealing with quantitative data. There's no qualitative here, only quantitative data. You can order the data. However, 0 simply represents a position on a scale. It doesn't imply the absence of something. It's just a position. For example, if you take the temperature scale, having 0 degrees does not mean there is absence of temperature. It's just a position on that scale. If you take, for example, the pH scale, different numbers on that scale simply represent different points. You need to interpret it based on the scale. Now, differences between data entries is meaningful. Of course, you can say 2 degrees is, so you can do 2 degrees minus 4, and you can say, there's a difference of 2 between that temperature. It's meaningful to do differences. The main thing to retain is that 0 on an interval level of measurement, 0 is just a position on the measurement scale. It doesn't mean the absence. On the other hand, you have ratio level of measurement similar to the interval level. The only difference is that 0 means there is absence. It means nothing. So if you go to the bank and you have 0 on your bank account, 0 money, it means there is no money. So don't go to the bank and say, my quantitative analysis teacher taught us about the interval level of measurement, and this 0 is just a position on the scale. No, 0 means nothing. Or on your QA test, if you have 0 on a question, it means you got nothing for that question. Now let's take some examples. Here, two data sets are shown. You have these two data sets. Which data set consists of data at the interval level? Which data set consists of data at the ratio level? Here you can see it says New York Yankees World Series victories in years. Of course, when you think of years, the calendar is simply a scale. So the different years mean something. Okay, so to be at year, if there's anything like year 0 when they started counting, if there's anything like that, it doesn't mean there's absence of years. It's just a point on that scale. It's a point on that time scale. On the other hand, if you take a look at the number of runs which someone did, home runs, you'll see that if you have 0, it simply means you had no home runs. So basically, you are dealing with a ratio, because here 0 means there is nothing, but here, if there is anything like year 0, it simply means it's a position on that scale. Interval ratio. Now let's take a look at another concept. We want to take a look, when you want to design a study, when you want to do research and you want to design a statistical study, the first thing that must be clear is you have to identify the variables. So generally, we want to first of all have a research topic, then we move on to a research question, then we have a hypothesis. Once we have a hypothesis, we need to identify the variables of interest. In other words, the focus. Because for you to test your hypothesis, you need to know what you go out to measure. So identify the variables of interest and the population of the study. What's your population of interest? Because once you know your population and you know the variables, then you can develop a detailed plan for collecting data. Now, if you are not collecting data from every member of the population, which is generally known as a census, it means you are taking a sample. If you use a sample, make sure the sample is representative of the population. Let's take an example. If you want to find out the academic performance and the amount of time people spend on social media, let me take another example. Or you want to find out the amount of time people spend on social media and the level of self-esteem. Those are two variables. You can ask people on average, what's your level of self-esteem from a scale of 1 to 5? And you can also ask people on a scale of 1 to 1, of 0 to 100, what's your average this semester or last semester, or how much time do you spend on social media? Of course, we are talking of time on social media and level of self-esteem. So you have to ask, on a scale of 1 to 5, level of self-esteem, and on average, how much time do you spend on social media per week? Then, based on that, you can go out and collect the data you need. Once you collect the data, you now need to describe the data using descriptive statistics techniques. We are going to be seeing that in this class. Then you need to interpret the data and make decisions about the population using inferential statistics. You see, we go from sample and then we make decisions about the population. We are interested in the population. However, it's too expensive, or it will take too much time to deal with the population. So we go through the sample and end up with the population. And you identify any possible errors and deal with the errors. Now, what are the main methods of data collection? One of the approaches, we are just going to look at some, not all of them. You have the observational study, where you simply go out and you observe people. Okay, you determine what your variables are. What are you observing? Then you go out and you observe. What are you observing? What's your population? Then you do it. A researcher observes and measures characteristics of interest of part of a population. For example, a researcher may observe and record the behavior, the mounting behavior on known food objects of children up to 3 years old. So a researcher can do that if that's their field of interest. Now, on the other hand, we also have a different data collection method known as experiments. An experiment, you do something and then you observe the impact. You can give someone medication and you find out if a change has occurred due to that medication. So a treatment is applied to part of a population and responses are observed. Now, let's take an example. An experiment was performed in which diabetics took cinnamon extract daily while a control group took none. Now, it's important to distinguish between the treatment and the control group. The treatment group are those who receive the treatment, they took it. The control group, they took something which is really not that. They thought they were also taking cinnamon, but they were taking something that was nothing. Some call it the sugar pill. So the researcher or someone else knows who is the control and who is not the control group. Why do they do that? Just to make sure that the effect they observe is as a result of the treatment that was applied. That's why. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease while the control group experienced no change. So this is an experiment where something is administered, then the effect of that is investigated. And we always use control groups. Now let's take a look at simulations. When you think of simulations, you are looking at using a mathematical or physical model to reproduce the conditions of a situation or a process. And you are generally using computers. It's really a mathematical approach to try to reproduce conditions of a situation or of a process. We will not be using that in this class. It's really used in industry a lot. Okay, I think we don't want this video to be too long. We'll stop here and continue next time.